Hello everyone, and welcome back to TechBees. Today we are going to do the second part of video series on Tensor Processing Unit, TPUs, and shall discuss the generations and architecture of TPUs. It's a technical presentation of the latest technology and is made for education purposes only. So, let's get started. Types of TPU. There are 3 generations of TPUs, which we shall see one by one. First generation TPU. The first generation TPU is an 8-bit matrix multiplication engine, driven with sys instructions by the host processor across a PSI 3.0 bus. It is manufactured on a 28nm process with a die size less than 331mm². The clock speed is 700 MHz, and it has a thermal design power of 28 to 40 watts. It has 28 MB of on-chip memory and 4 MB of 32-bit accumulators, taking the results of a 256x256 systolic array of 8-bit multipliers. Within the TPU package is 8 GB of dual-channel 2133 MHz DDR3 SDRAM offering 34 GB per second of bandwidth. Instructions transfer data to or from the host, perform matrix multiplications or convolutions, and apply activation functions. It was developed to accelerate the machine learning workloads from Google Data Center. Second generation TPU. The second generation TPU was announced in May 2017. This CPU is now available in cloud and also known as Cloud TPU and supports training and inference. Google stated, the first generation TPU design was limited by memory bandwidth and using 16 GB of high bandwidth memory, and the second generation design increased bandwidth to 600 GB per second and performance to 45 teraflops. The TPUs are then arranged into 4 chip modules with a performance of 180 teraflops. Then 64 of these modules are assembled into 256 chip pods with 11.5 petaflops of performance. Notably, while the first generation TPUs were limited to integers, the second generation TPUs can also calculate in floating point. This makes the second generation TPUs useful for both training and inference of machine learning models. Google has stated, these second generation TPUs will be available on the Google Compute Engine for use in TensorFlow applications. Cloud TPU chips are interconnected, and therefore communication between chips does not have to involve the host CPU or host networking. The APIs used to program Cloud TPU can take advantage of Cloud TPU pods without code changes. As a result, it is easy to scale up to massive compute clusters. The hardware support built into the chips results in effectively linear performance scaling across a broad range of deep learning workloads. Third generation TPU. The third generation TPU was announced on May 8, 2018. Google announced that processors themselves are twice as powerful as the second generation TPUs and would be deployed in pods with 4 times as many chips as the preceding generation. This resulted in an 8-fold increase in performance per pod compared to the second generation TPU deployments. TPU Architecture. There are 2 TPU architectures. First, software architecture, and second, hardware architecture. Let's discuss software architecture first. Software architecture. The TPU estimators are a set of high-level APIs that are built upon estimators, which simplify building models for Cloud TPU and which extract maximum TPU performance. When writing a neural network model that uses Cloud TPU, you should use the TPU estimator APIs. TensorFlow client. The TPU estimators translate your programs into TensorFlow operations, which are then converted into a computational graph by a TensorFlow client. A TensorFlow client communicates the computational graph to a TensorFlow server. A TensorFlow server runs on a Cloud TPU server. When the server receives a computational graph from the TensorFlow client, the server performs the following actions. First, loads inputs from cloud storage. Second, partitions the graph into portions that can run on a Cloud TPU and those that must run on a CPU. Third, generates XLA operations corresponding to the subgraph that is to run on Cloud TPU. Fourth, invokes the XLA compiler. XLA compiler. XLA is a just-in-time compiler that takes as input high-level optimizer operations that are produced by the TensorFlow server. XLA generates binary code to be run on Cloud TPU, including orchestration of data from on-chip memory to hardware execution units and inter-chip communication. The generated binary is loaded onto Cloud TPU using PSI connectivity between the Cloud TPU server and the Cloud TPU and is then launched for execution. Hardware architecture. Cloud TPU hardware is comprised of 4 independent chips. The following block diagram describes the components of a single chip. Each chip consists of 2 compute cores, called tensor cores. A tensor core consists of scalar, vector and matrix units. In addition, 8 GB of on-chip memory is associated with each tensor core. For Cloud TPU v2 and 16 GB for Cloud TPU v3. The bulk of the compute horsepower in a Cloud TPU is provided by the matrix units. Each matrix unit is capable of performing 16K multiply accumulate operations in each cycle. While the matrix in its inputs and outputs are 32-bit floating point values, the matrix units performs multiplies at reduced bfloat 16 precision. Bfloat 16 is a 16-bit floating point representation that provides better training and model accuracy than the IEEE half precision representation. Matrix multiplier unit, MXU, is 65, 536 8-bit multiply and add units for matrix operations. Unified buffer, UB, is 24 MB of SRAM that work as registers. Activation unit, AU, is hardwired activation functions. Built for artificial intelligence on Google Cloud. Architected to run cutting-edge machine learning models with AI services on Google Cloud. Cloud TPU delivers the computational power to transform your business or create the next research breakthrough. With a custom high-speed network that allows TPUs to work together on ML workloads, Cloud TPU can provide up to 11.5 petaflops of performance in a single pod. Okay everyone, that's all in this video. The TPU applications are explained in the next video. Do check it out. Also, if you like this video, then do like, share and subscribe to our channel. Thank you.